Hello everyone. In this video, we are going to learn how to do forecasting by using exponential smoothing method. Well, exponential smoothing model, it is also a straightforward model, but it's very efficient. So it is completely based on this simple function as you see here. So the simple function can be also rewritten in this form. Let me explain what these symbols are. So we do have very important constant that's called alpha. Okay, so alpha is very important here. It's a user specified value, but at the end of this lecture you will learn how to optimally locate this alpha. This should be between 0 and 1. It can be equal to 0, it can be equal to 1. Okay, and it's called the smoothing constant. In this in this function, the ft plus 1, it means that we are making a forecast for the time period 1, just one time period ahead of us, okay? So we're assuming that we are here at time period t and we are making a forecast for ft plus 1. So f stands for the forecast for t plus 1, time period t plus 1, okay? And ft is then the forecast that we made for time period t, okay? If we are at time period t, for example, we must have made a forecast for this time period, plus alpha, the smoothing constant, times the actual observation that we see in time period t, okay? So if you rearrange these right hand side, you will end up with this one. Okay, so basically these guys are identical. All right, it's very simple, but be careful that you have to incrementally update this formula every time you have an actual observation. Okay, so whenever you have another observation in your record, then you will come here and then you have to update your forecast formula. Okay, we will see that over some examples. Okay, let's move to the next page. So here for the monthly burglaries data, we also did some exponential smoothing analysis. Let me get this closer to the screen. Okay, so here, if you remember, hey, we have for a specific month, we have the monthly burglaries data. What's so important is to be able to start exponential smoothing. So in this example, the first observation, okay, the first monthly burglary number is taken as a forecast for the exponential smoothing method, okay? And these are the alpha values. So for each specifically different alpha value in an increment of 0.1, here you can see in these columns the different forecast values for this problem, okay? So what happens here is that if you click on this one, okay, so this is actually the C5. C5 is our previous demand for the previous month, right? So it is actually our forecast value, which is F1, okay, plus C4. C4 is our smoothing constant times the difference between the demand B5 and then the forecast value that we produce for the first month. Okay, so this function is basically the second function that I showed you on the presentation. But what happens here is that as you have a new demand data point, okay, this one became available, let's assume, okay, and then you still have to update your forecast for the future months. So let me go back. So this forecast is valid for, let's say, month 44, 45, 46, 47, okay? But as this new data point becomes available, I have to update this forecast to this one because I now have more information about the future. Okay, I have to incrementally update this every time I have a demand point until the time period 58. Okay, here I got an observation here, and then I have to update this formula based on my previously made forecast value 66.16, and also my the most current available monthly burglary data, which is 71, and also I just basically used the same formula that I used before. So I updated my formula according to that function, and now my future demand, sorry, my future forecast for the month 58 and onward is 66.65. I didn't stop there because now I had also a new data, which is 50 here, right? From this point forward, I have no data points, and then I still have to update this forecast value. So at the end of this data, right, my forecast for future is exactly 64.98 if you are using this exponential, this smoothing constant, which is 0.1. Well, this column does the same thing, but this time 0.2 is the smoothing constant. In this column, 0.3 is the smoothing constant, so on and so forth, all the way up to 0.9. So now the question is, which one is best? What do you think? All right, so let's try to figure it out if we can visually. Let's see what's happening here. Let's draw a chart. Let's see if it worked. I don't think it is easy to see that, but if you remember from the moving averages method, in order to differentiate this method from the others, like to select the best one, what you need to do is you need to calculate the error values, right? So I don't think I calculated one for this example, but for the next example, we are going to calculate it together. Okay. So this is basically the screenshot from this Excel spreadsheet. So here is the class exercise. It says find the best value of smoothing constant between 0.5 and 0.7 in increments of 0.05 for exponential smoothing for the burglary data. Okay, so we are still going to be working on the same data, but this time we are going to change the smoothing constant value from 0.5 to 0.55 to 0.60, 0.65 to 0.70 in order to get the best exponential smoothing value or the forecast value for this problem. Okay, I already provided the template for you here. These are going to be your exponential smoothing constants. As you can see, your error values are going to be automatically updated. It's just the difference between the actual observation and the forecast. And this relative error measure is going to help us calculate this MAPE error value. Okay, these are just specifically designed for it, not different than what you did before for moving averages. So that's why I gave them to you. All you have to do is to figure out how to write the forecasting functions incrementally for for alpha is equal to 0.5 all the way up to 0.70 in the increments of 0.05. So if you remember, this was our function, right? So when I come here, ft plus 1, my forecast value for the one period ahead is going to be equal to 1 minus alpha times ft plus alpha times at. Okay, so let me come here. So what is my formula? So my formula is equal to, my forecast here is 1 minus my smoothing constant 0C4, that's right there, times my FT. My FT is my forecast that I made previously for the previous month, which is 88 in this example. Remember, I took my first observation as my forecast. You can also do this for other assignments unless otherwise stated. Sometimes questions specify exactly what should be the first month's forecast if you're dealing with exponential smoothing problem. That's problematic because this incrementally increasing functions. Remember, ft plus 1 is equal to 1 minus alpha times ft plus alpha times at. So, for example, if you are at t period is equal to 0, so if you are here, and what was the forecast you made for this period, right? So here you don't know that, so you have to come up with a forecast value. So in this example, we just took the demand and then we set it equal to our initial forecast values. Okay, let's keep going. So the formula is 1 minus alpha. Alpha is stored here at C4 times our previously made forecast FT, in this case F42, which is 88. It is stored right here. I'll select that. Okay, plus alpha times AT. Alpha times my actual observation in this time period. My alpha is right here, times my actual observation stored in B5. Okay, so this is the actual observation that I received for the month 42. That's why I have to update this formula, and this is my forecast for this time period. Okay, hit OK. Well, this is 88. No shocking, because my previously obtained demand point is 88, and my forecast for this month is 88. So 88 times alpha plus 1 minus alpha times 88 is going to give me the 88 exactly. But from now on, it's going to change. Well, how do I update this formula? So let's try to drag it down, and let's see what happens. Oh my god, these numbers are completely different numbers. So let's see if my formula is messed up. Yes, because it's no longer selected here. My alpha constant was dragged down to the cell right beneath it. So how do you prevent this from happening? Well, you have to come here. Let me first delete them. You have to come here, and you have to make sure that this C4 has a dollar sign between C and 4. Make sure that you also put it here as well. Okay, and also this B5 is the cell that keeps my monthly burglaries actual observations. It has a dollar sign right in front of it. Sorry, right after the star. If I can get there. Okay, here. What's not happening? Okay, I guess it is going to happen. All right, that's what I'm talking about. So what this dollar sign in the middle does, it fixes this cell that you selected, C4, when you drag this cell down. Okay, so what happens here, the dollar sign in front of this cell number, it's going to be fixed. This cell B5 is going to be fixed when you drag this cell from this dot at the bottom right corner from left or right. Okay, so let's try this one this time. Okay, so let's grab this and let's go all the way to down. Let's see what's to happen. Uh-oh, something went wrong. So this one is okay. Let's see what happened to this one. So it grabbed C1 minus C4 times C6 plus C5 times B6. Okay, we didn't specify this correctly, that's what. So we had to put this dollar sign between C and 5. Okay. Uh-oh. Okay, so here I had to do that, sorry. CM4. Let's try one more time. Okay, now it looks more reasonable. As you can see now, if you check out the cell, it is 1 minus alpha, exactly right here, times my FT. FT is the forecast made for my previous month, plus my alpha times my actual observation that happened here. Well, check this one or this one. Okay, so this one is also equal to 1 minus alpha. Alpha is right there, times C8. C8 is the forecast made for my previous month, plus alpha times B8. B8 is stored right here. Okay, so this is working correctly. So let's try to drag it to the right. Let's see whether it is going to update it. Exactly, yeah, everything you saw in this column transferred to this column accurately. So you can also drag this down. Or if you double click on that corner, it's also going to do the trick. Oh no, it didn't, sorry. Because it messed up my error values. I don't want that. Alright, let's go all the way back because it messed up my error values here. Well, this is learning by exercise. So if you are a stranger to Excel, this will also help you a lot. Yeah, let's go back. Yeah, I think this is where was the last time I kept these values correct. Okay, so now let's go ahead and then fix this error. C4 and $sign goes right there. Let's manually do that. Okay, so this guy is correct. So if you select them, then drag it all the way to the right, here it is. Everything is updated now. So under 0.5, 0.55, 0.60, 0.65, and 0.70, now you got the forecast values, okay, for these months. And the error values are automatically calculated. Relative error values are automatically calculated as well. Here what you see here is the MAD, MSE, and MAPE. So if you carefully analyze them, you see that the minimum error values are obtained, I guess, right here. So this is the champion, because this smoothing constant gave me the minimum error value. So your conclusion can be, hey, out of these range, 0.65 gave me the best error values, the minimum error values. Therefore, if you are going to use exponential smoothing, we highly suggest you to use alpha constant as 0.65. That's it. That's how we solve the example on this slide. Okay, moving on. Here's another exercise. So it says exponential smoothing versus moving average. It says that observed weekly sales for a product have been 14, 9, 30, 22, 39, 12, 19, and 23. Use moving average with K constant equals to 3 and determine one step ahead forecast for weeks 4 through 8. And in part B, it says use exponential smoothing with alpha value is equal to 0.15 and determine one step ahead forecast for weeks 4 through 8. Here's a hint. Remember, it's problematic because in exponential smoothing, we need to know how to initiate this formula, right? Ft plus 1 is equal to 1 minus alpha times Ft plus alpha times At. That's the problem, because it needs the data from the previous observation. So if you are at the very start, it becomes problematic to initiate the data. But this hint tells you that to get the method started, use the same forecast for week 4 as you used in part A. Hey, this is something different, right? And then see, based on the MAD, which method did better. So we have to calculate MAD, mean absolute deviation, so that we can decide. What is exponential smoothing and MA forecasts made at the end of week 6 for the sales, week 12. Okay, I already solved this for you. here's my solution. For part A, what I did is I just wrote down the number of weeks here, right? And I wrote down the sales. And for the moving averages with k is equal to 3, I don't know for the first 3 months. I don't know what my forecasts are. Starting at the week 4, I can get the averages of these most current sales values in the previous 3 weeks and then calculate my forecast, right? And I can keep doing that by updating my formula incrementally. Okay, so this is my moving averages in part A. In part B, I was asked to use exponential smoothing, but my assumption is that, okay, in part A, the first formula, the first forecast value you calculated, I could have the option to take it as it is, 17.67. Well, I took it right there, right? And then I implemented the formula that says ft plus 1 is equal to ft plus alpha times at minus ft. Here, starting from week 5, because I had the new data availability, right? I had to update this function. So my f5 is equal to f4 plus 0.15 times 22 minus 17.67. And then I kept doing that until I reached week 8. Okay, that's part B. So here I had to calculate my error values, right? Okay, so these are the forecasts that I made by using moving average with k is equal to 3, and these are the forecasts for these weeks I made by using exponential smoothing with alpha value 0.15. Let's keep going. Here, you have to take the differences at the error values in absolute value, right? So this is for moving average and this is for exponential smoothing, and you have to add them up and take the averages. If you do that by using moving averages, your MAD value is 7.934, and by using exponential smoothing, your error value is 6.54754. So which one is preferred? Definitely the one that gives you the minimum MAD value. So in this case, exponential smoothing gives you a better objective function, better error value. So go with that. And the last question was about, let me go to the last question. So that question was about what is exponential smoothing and moving average forecasts made at the end of week 6 for the sales 12. So the question asked me to make a forecast at the end of week 6 for the week 12. Okay, here let me go back to my forecast. So by using moving averages with k is equal to 3, if I'm at the end of week 6, it means that I had this value already observed, right? And I had to update this forecast accordingly. So my forecast at the end of week 6 is updated, which is 22.67. And similarly for exponential smoothing, at the end of week 6, I had this value available, and my forecast is for week 7 is equal to 19.37. Well, guess what? If you don't assume that you have more data for week 7 and week 8, this is also the forecast. 22.67 is also the forecast that you have to have for week 12. Okay, that's not the case because you have the data availability, but the question says at the end of week 6, what was your forecast you made for week 12? The answer is 22.67 by using moving averages. Okay, and by using the exponential smoothing, the answer is 19.37 right there. Okay. So here you can also add another index here. It says the first initial index is at the end of week 6, and our forecast for week 12 by using exponential smoothing is 19.37, and by using moving averages it is 22.67. Okay, what is my forecast for the week 50, for example, if I'm at the end of week 6? By using exponential smoothing, it is exactly this value again. It's not going to change because we're going to assume that nothing has happened after week 6. That's not the case again. If you would like to use the most accurate values, the observations, then you have to use this guy right there at the end for the future forecast. Okay? Alright, that I believe concludes this video. Thank you for watching.